Now let's start talking about gossip. We saw at the time of Bootstrap, somehow the node that the incoming node was gossiping with was able to tell, hey, you know what? Don't bother about that node. It seems to be down. Now, let's take a look at the word gossip. There's a negative connotation in English, isn't it? Gossip monger, someone who just gossips around and doesn't do any work. Anyway, right? But you know what? While gossip has a negative connotation, right, it also has a very, you can look at it from a positive perspective as well, right? For instance, gossip allows dissipation of information, right? And I'll tell you what kind of information travels really fast? Bad news. Bad news travels really fast. And when you're talking about a distributed system such as this, what is bad news? Bad news is there is a node that is down and I don't know about it. And because of that lack of awareness, I may try to contact that node and eventually time out. Timeout is a very expensive activity, isn't it? Because I could have set the timeout of 10 seconds. So it's going to be 10 seconds and, times as many number of zeros, that many microseconds before Cassandra actually times out. And I already talked about in Cassandra, we are going to, try and talk about in microseconds. And if you scale that, you saw micro to milli really moves over from days to months when you're talking about human scale, right? So seconds is obviously out of the question. So there has to be something that allows Cassandra to exchange information for a given cluster, within a given cluster, about a given cluster. So let me draw our good old 4-node Cassandra cluster. That's N1, N2, N3, and N4. I'm not having another node N5. So what does gossip do? Every second, each node can gossip up to 3 other nodes and share the load information of itself and others that it knows of. Let me repeat. Every second, Cassandra gossips to up to 3 other nodes about the load information of itself and others that it knows of. So if I were to draw this out, so N1 at time T1 about this time is gossiping with N2 and it's saying, hey, you know what? My load information is, let's say 1.5. And by the way, N2, your load information is 2.2. N3's load information is 1.8 and N4 is generally having fun at 0.4. No load information of itself and others that it knows of, it's communicating with N2. How does this make sense? Does this make sense? Imagine you are a Cassandra node and you are talking to another Cassandra node and saying that, hey, your load information is this. N2 is going to say, hey, wait a minute. I think I know about my load information. You don't tell me that. You don't need to tell me that. So let me modify the statement. At every second, it is gossiping with every other node to share the load information of others of itself and others that it knows of minus the node that it's gossiping with. Logical, right? So it's not going to include this for obvious reasons. Further, what it also expects is, because this is a masterless architecture, it is possible that N3 has already gossiped with N2 And according to N2, N3's load information is 1.2. Let us assume. And N1 is trying to say, hey, N2, N3's load information is 1.8. There is a conflict. You can clearly see there is a conflict. N1 is saying this is the fact, and N3 has said this is the fact. Logic is simple. In Cassandra's gossip information, by the way, this is gossip information. So it has load information plus a whole bunch of other things. We're going to build up that story as we move on forward. So N2 essentially is going to say, okay, I now have 2 points in, points of truth. Which one is real? Right? Which one is real? The one with a later timestamp. So gossip contains the load information plus timestamp. Okay? Plus timestamp. So whichever is the later timestamp wins. So if N3 gossiped with N2 after N1 has gossiped, then N2 is going to override N1's gossip information with N3 and vice versa. So what is happening is the cluster is abuzz over the network sharing this load information along with the timestamp and I would say other elements of data. And we are going to build this as we move on forward, as I mentioned. Advantage? Consider this. If N3 stops gossiping, what will end up happening? This gossip information will begin to become stale. Right? It will begin to become stale. So N2 will say, hey, wait a minute. Everybody seems to be saying the exact same information about N3. Why is this information not changing? Now you might wonder, wait a minute, maybe the load is constant. If the load is constant, why will this information change? And if this information doesn't change, how does the node know that N3 is indeed not gossiping? So that means this load information alone is not sufficient. I need something else. Heartbeat. So along with the load information and timestamp, it also shares the heartbeat. If the heartbeat stays constant over a period of time, or a number of gossips that a node hears from the other nodes, then this node will begin to become suspicious. Okay, so I don't particularly care about the load information, but the heartbeat is staying constant. Heartbeat has to change. You get that? So now consider a situation where N3, and I'm going to try and draw it in a different color. So N3 gossiped with N4. This is, let's say, heartbeat equal to 1, right? And then N3 may have gossiped with N1, heartbeat equal to 2. And then N4 is gossiping with N2 and it says heartbeat equal to 1. N2 is gossiping with N1 is gossiping with N2, sorry, and it says heartbeat equal to 2. And remember, it's all about N3. This node is in focus. N2 will say, okay, good. Right, so I had heartbeat 1, then I had heartbeat 2, so it's changing. So I know for a fact N3 is gossiping. It may not have gossiped with me just yet, but by virtue of other nodes gossiping, I know, yeah, N3 is up and running. It's a logical conclusion. It's a logical conclusion. In a distributed system, there is only one guarantee that you can potentially get. And that is, there are no guarantees. You make sense, right? So just think about it like this. How do I know in a cluster of few nodes or large number of nodes, a given node is not available? I can only logically conclude by virtue of the heartbeat staying constant over a period of time. And the way that can happen is multiple nodes are saying exactly the same heartbeat over a period of time. That's when a node will mark the other node whose heartbeat has remained constant, right, as down. It's a logical conclusion. Maybe that node is up and running. Maybe it lost network connectivity.